Hello everyone, this is hw8. In this video, I will solve question 2 in homework 8. For this question, we have already know that n is a Poisson process with parameter lambda. So the Poisson process usually follow this kind of formula. That is, the probability of numbers in t1 and t2 equals to k. Then the probability should equals to e to the power of minus lambda t2 minus t1 times lambda t2 minus t1 to the power of k and divided by k factor. And for the first question, we need to find the probability that x of t equals to 1. It should be equals to the probability that numbers in between 0 to t equals to k is even. So then follow this formula, we should get the answer is e to the power of minus lambda t times lambda t to the power of k and divided by k factor when k equals to 0 to 4 until 2 times k. To solve this formula, we should know the Taylor series first. So in Taylor series, the e to the power of lambda times t should equals to 1 plus lambda times t plus lambda times t squared divided by 2 factor plus lambda times t to the power of 3 divided by 3 factor and plus lambda to the power of 4 divided by 4 factor. This function we named it first function 1. And to similarly, if we look at the Taylor series for the exponential function of e to the power of minus lambda times t should equals to 1 minus lambda t plus lambda t squared divided by 2 factor minus 2 lambda times t to the power of 3 divided by 3 factor and plus lambda times t to the power of 4 divided by 4 factor. This is function 2. So right now, we just need to add function 1 and function 2 together. And then we can get that is 2 times 1 plus lambda times t squared divided by 2 factor plus lambda t to the power of 4 divided by 4 factor and so on. From this, we can get the e to the power of minus lambda times t, lambda times lambda t to the power of k divided by k factor when k is equal to 0 to 4 to k is equals to 1/2 times e to the power of lambda times t plus e to the power of minus lambda times t and times e to the power of minus lambda times t, and the answer should be is 1/2 times 1 minus e to the power of minus 2 times lambda times t. So this is the answer for the probability of when x of t equals to 1. Now for the question B, we should find the expectation of x of t. So if we just conduct the function 1 to minus the function 2, then we can get the probability of when x of t equals to minus 1 is equals to 1/2 times 1 plus e to the power of minus 2 times lambda times t. And then we can get the expectation of x of t equals to 1 times the probability of x of t equals to 1 plus the minus of 1 times the probability of x of t equals to minus 1. The answer is minus e to the power of minus of 2 times lambda times t. This is the answer for the expectation of x of t. Now, for the part 3, we need to find the autocorrelation of T1 and T2. For this part, according to the definition of autocorrelation, we should get the RT1, T2 equals to expectation of x of T1 times x of T2. And since from this question, we already know that x T1 times x of T2, we got two conditions. One is this value should equals to 1. So in this case, maybe the x of T1 equals to 1, and also the x of T2 equals to 1, or the x of T1 equals to minus 1, and the x of T2 equals to minus of 1. For this value, for the another case is their multiplication value is equals to minus 1. In this case, maybe that x of T1 equals to minus 1, and in this case, the x of T2 should equals to 1, or the x of T1 equals to 1, and the x of T2 equals to minus 1. So if their multiplication value equals to 1, that means that means the probability in T1 and T2, the number of k is even. Or for the minus of 1, in T1 and T2, the number of k is odd. So then this function should equals to the probability of the x T1 times x T2 equals to 1 minus the probability of x T1 times x T2 equals to minus 1. So in this case, we just considering these conditions to here, and then we can get that 1/2 times 1 plus e to the power of minus 2 times lambda T2 minus T1, and minus 1/2 times 1 minus e to the power of minus 2 plus times lambda times T2 minus T1, and this should be the e to the power of minus 2 times lambda times T2 times minus T1. This is only in the condition when T2 is greater than T1. So if T1 is greater than T2, the autocorrelation function of T1 and T2 should equals to the e to the power of minus 2 times lambda times T1 minus T2. So if we set the T1 minus T2 equals to T, then we can get this. In conclusion, we can, considering all the conditions from the previous we have already got, then we can get the autocorrelation of T1 and T2 equals to e to the power of minus 2 lambda T2 minus T1 when T2 is greater than T1. Otherwise, when T2 is less than T1, we should get the answer is e to the power of 2 minus 2 times lambda T1 minus T2, and it's also can written like this is the absolutely value. We just change this part is the absolutely value of T1 minus T2. So considering all the information we can get, we can make sure that the autocorrelation is wide is white SS.